Hello. So we're going to start our lectures on how to convert schemas into relational databases and how to start running queries against these databases. So to begin with, we're going to have a schema that we're going to be using a lot. So this will be the main schema that we use for all our examples. It consists of 5 tables: movies, movie stars, stars in, movie execs, and studios. And what these tables do is they store data about, well, movies that have come out, who's starred in them, who made them, that type of information. So we'll be able to do some queries on that. So here's the schema about movies, okay? And we've seen a version of this before, but this is just a little bit bigger. So we have a title and a year; those are the keys, and then we have the length, in minutes of how long the movie is, the genre, and we're adding the studio name and also a producer C number. I always read that as C sharp, but it's not. It's C number. And this producer C number is the certificate number of the person who actually is in charge of this movie, producing it. Okay, so those are the 2 things that we've added. Here is the movie stars, and what that has is a name. This is the name of the star, like Carrie Fisher, and that is the key. Typically, you wouldn't do that. You wouldn't assume that 2 people with the same name are actually the same person. But for movie stars, it makes sense just because movie stars are very protective of their name. So if one star actually had a name that was too close to another one, he or she would be more likely to change that name than to continue. So name is unique for this particular purpose. We also have an address, which is just where they live, gender, and a birth date. One thing that you might notice is that they have new domains that we're introducing here, car and date. Here is stars in. This is another table. The purpose of this table is simply to let you know which star is in which movie. So you see the names of the attributes here. We have movie title and movie year. Well, those 2 together uniquely determine a movie. So that is Star Wars 1977. We know what movie we're talking about, right? It is unambiguous. That's the whole point of keys, right? This is actually the key of that table, title and year. We call those movie title and movie year to make it clear what table they come from. Now, another attribute in this row is a star name, and that is the name of the movie star that's supposed to be acting in that movie. So Star Wars 1977, Carrie Fisher, okay, would make sense. And each row actually does just that. It connects one movie with one movie star, okay? Of course, you can have many rows with the same movie. So Harrison Ford and Mark Hamill also starred in Star Wars 1977. And Harrison Ford starred in many other movies. For example, he was in Indiana Jones, okay? So you have this relationship between movies and movie stars, where a movie can have many movie stars, and a movie star can be in many different movies. Okay. Now here's another table that we're storing. It's movie execs, and again, an executive would have a name and an address. I'm no longer going to assume, or actually, the book's no longer going to assume that people with different names are actually different people. And the reason for that is that movie executives are not like movie stars. By nature, they're in the background. And so since they're in the background, they don't really care if there's another executive with the same name. So we need some other way of differentiating them, and that's where synthetic keys come in. We'll generate a synthetic key for a movie executive, and that is their certificate number, okay? That might actually correspond. So it might really be semantic, because it might actually correspond to, say, a number that's given to them from one of the guilds, that's used in the movie industry. But regardless, that's just a key that we can use to separate executives. Now, the other thing that we're throwing in there is a net worth. We'll use that later, okay? Just a quick note. Remember that movies have producers, and what we did was we had an attribute called producer C number, okay? And that's the value that we would put here in their certificate number. So what that means is that a movie, which is a row in that table, can have just one executive, right? It's not like the stars where you can have many stars in a movie. There's only one producer. That may not be realistic, but it's what we're running with, and it's just gives you an example of something that has just one row associated with a different row. Okay. All right. The last one that we have is studios, and this has a name. And again, we're assuming the names are unique, and this is because a studio name is like a company name. You simply can't go out and create a company called, say, Google, okay? Because if you try that, Google will send you a cease and desist letter very, very quickly. So yeah, names of studios are unique, and we have the address, and we also have the certificate number of the president, so that lets us know who is in charge of that studio names. By the way, there's an assumption we're making here. It's not a deep assumption, but it's a minor assumption, and that is that studios don't change names, because since we're made that the key and a studio changes its name, we have a lot of work to do. Like I told you, changing primary keys is very, very difficult in databases. So we're taking a risk in this schema, but we'll stick with it.